Good morning, dear students. Our lesson today, 7.4, find distance in the coordinate plane. Today, we will use the Pythagorean theorem to find the distance between 2 points in the coordinate plane. Page 402. Read this question. What the distance between points A and B? Look at the graph. In this lesson, we will use the Pythagorean theorem to find the distance between A and B. So, we must draw a right angle triangle in which AB is a hypotenuse. So, we must draw a horizontal segment from B, here it is, and a vertical segment from A to meet together. Then join AB, this is the hypotenuse and this is the required. Now, how to find the length of the hypotenuse using the Pythagorean theorem? Of course, it's square root. The horizontal segment equals 2 steps and the vertical segments equals 2 steps. So, square root 2 squared plus 2 squared. Of course, 2 squared is 4, so it's square root 4 plus 4, square root 8. Now, you can use the calculator to find approximated value for root 8. Of course, it will be before 3 because square root 9, the positive square root of 9 is 3. So it must be less than 3. Yes, using the calculator, it's about 2.8. Are you happy with this? Yes? Okay, then go to the next question. Page 404. Read question 4 carefully. The question is, use the coordinate plane below to find the distance between points C and D. Round the answer to the nearest hundredth. Look at C and D. Think how to draw a triangle. Contains CD as a hypotenuse. Yes. This is the horizontal segment. And this is the vertical segment or the vertical leg. Now connect CD to complete the triangle. We have a right angle triangle now, and CD, the required, is the hypotenuse. Then use the Pythagorean theorem to find the hypotenuse. You can stop the video and do it. Have you finished? Yes? Okay, check your answer with me. CD, the hypotenuse, equals square root of 1. The horizontal leg is 1 step, so it's 1 squared. And the vertical leg or the vertical distance equals 3, so it's 3 squared. Find the value of square root 1 squared plus 3 squared. Of course, 1 squared is 1, 3 squared is 9. So it's square root 1 plus 9, it's square root 10. Now, use the calculator to find approximated value for square root 10 to the nearest hundredth. Yes, it's about 3.16. Are you happy with this? Yes? Now, go to question 5. Have you finished question 5? Yes? Okay, check your answer with me. Of course, the first thing we must determine the triangle CDE. So connect CD and DE. Of course, we must complete the triangle and connect CE. This is the triangle. We have 3 sides or 3 segments, the blue one, the yellow one, and the red one. The blue one is CD and we already have CD. It's about 3.16 as we said. Now, the yellow segment or the yellow side, DE, we can find this by counting how many steps or how many units from C to E. Yes, DE equals 4 units. The last side, CE, the red side. How to find this red side? We cannot find this side using counting, so we'll use the Pythagorean theorem to find CE. So already we have a triangle, and CE is a hypotenuse in this triangle. Where is this triangle? Yes, here it is. So now we will use this right angle triangle to find the length of the hypotenuse CE. Of course, use counting to find the horizontal leg. It's 1, 2, 3, 3 units, and the horizontal and the vertical leg is the same, it's 3 units. Now use the Pythagorean theorem to find the hypotenuse CE. It's square root 3 squared plus 3 squared. Yes, 3 squared is 9 and 3 squared is 9. 9 plus 9 is 18, so it's square root 18. We can use the calculator to find approximated value for square root 18. Of course, square root 18, it's greater than square root 16. Square root 16, the positive square root 16 is 4, so it will be 4 and, or it will be a number, a decimal between 4 and 5. Yes, using the calculator, it's about 4.24. Now we can find the perimeter of the triangle CDE because we have all the sides. Yes, the perimeter is the sum of these 3 sides, 3 and 1600 plus 4 and 2400. Add now. The final answer is about 11.40 or 11.4. It's the same. Are you happy with this? Yes? Okay. Now go to question 7. Read the question carefully. Stop the video and do question 7. Have you finished? Yes? In this question, use the Pythagorean theorem to find the distance between the points P and Q. Look at the graph. As we said, we will use a right angle triangle, and the right angle triangle is already drawn. And the horizontal leg is, count, we can find this by counting, it's 6 units. The vertical leg, count to find the length of the vertical leg, it's 8. How to find PQ, the hypotenuse? Using Pythagorean theorem, it's 6 squared plus 8 squared, and of course we must add because this is the hypotenuse. How to find C? It's square root 6 squared plus 8 squared. Of course 6 squared is 36, 8 squared is 64, so the sum is 100. So C equals the square root of 100. Of course the positive square root of 100 is exactly 10. Are you happy with this? Yes? Okay, then we have another solution, remember? We can write a formula to find the distance between any 2 points in the coordinated plane. Look here. Of course, how to find the horizontal leg or the horizontal distance? It's 6. How come? 6 comes from subtracting 9 minus 3. Subtracting 9 minus 3, or the x minus x. If this is x1, then 9 is x2, so subtract x2 minus x1. And what about the 8? How come? we can only subtract the y minus the y. The 10 minus 2, 10 minus 2 is 8, so we can subtract y minus y, or y2 minus y1. Now we can write a formula to find the length or the distance between any 2 points in the coordinate plane. This formula is d, or the distance, equals square root of x2 minus x1 squared plus y2 minus y1 squared. We can apply this formula on this example on question 7. Now, question 14. Read carefully, take your time, stop the video if you want. After finishing, come back to check your answer. Have you finished? Yes? We can use the formula directly to find the distance between P and R. The question, find the distance between P and R, round to the nearest tenth. We have 2 points, so use the formula, the distance formula. Here it is. And subtract the x minus the x, the y minus the y, then find the square root of the sum. So it's 12 minus 5 squared plus 14 minus 10 squared under the square root sign. What's 12 minus 5? It's 7. Yes. What's 14 minus 10? It's 4. So square root 7 squared plus 4 squared. Of course, it's equal to square root 49 plus 4 squared is 16. So it's square root 65. We can use the calculator to find the approximated value. Of course, the value of this root will be greater than 8 because square root of 64 is exactly 8. So it will be 8 greater than a number greater than 8. Yes, it's using the calculator. It's about 8.1. Are you happy with this? Yes? Go to question 15. Try to use the distance formula to find the distance between A and B. Stop the video and come back if you finished. Finished? Yes? Okay, check your answer with me. We have 2 points. Use the formula. Subtract the x minus the x, x2 minus x1, and y2 minus y1. So it will be square root 5.5 minus 1 squared plus 9.25 minus 5 squared under the square root sign, the positive square root sign. Of course, we are using the positive square root because the distances are positive quantities. 5.5 minus 1, it's 4.5 squared plus 9.25 minus 5, it's 4.25 squared. Now, find the value of this expression. Using the calculator, it's about 6.2 because the question says round to the nearest tenth. So it's about 6 and 2/10. I enjoyed the session. Goodbye.